Here we are at the end of the semester talking about the last lesson of the course, substitution rule. Again, it's a very important concept because you're going to do a lot of integration in the following courses. So in order for us to use this method, of course, the name tells us a lot, substitution, we should remember composition of functions. So if you have f composed with g of x, right, that equals f of g of x, which means this function g of x is the interior function. So the key to this lesson is to figure out which one is your interior function and which one is your exterior function. So having g of x the interior function, we are going to use the substitution u. We are going to write this g of x as u. So looking at the, and then g prime of x dx equals du. So using this information, we are going to integrate. Now, let's see this problem. So you can read if you want the steps that we have for the procedure. And let's do the following problem. So look at this one. We have this function here, 2x plus 1 to the third. So that would mean that your g of x, your interior function, is 2x plus 1, right? And your f of x is x to the third. We don't even care about f of x. All we care about is g of x. So the steps were this function g of x that you figure out, so 2x plus 1, just substitute it with a u. So now if we differentiate the left-hand side with respect to x, we get 2 dx. Why? Because 2x plus 1, if you differentiate that, you get just 2. And we write dx because we differentiate it with respect to x. And on the other side, we just get du. So now using all this information, let's plug in. Or if you want, we can do one more step. Dx equals du over 2. So now I'm just going to start plugging in. You see how here we have 2. So I'm just going to copy it. So integral of 2 times. Now the next step is 2x plus 1, which we actually label it with u. So I'm going to put u to the power of 3. And then dx, well, we just wrote that dx is du over 2. So 2 and 2 cancels, and we ended up with integral of u to the third du. So basically, now we have an integral, an elementary integral where the variable is u. So integral of u to the third du, it's u to the fourth over 4 plus c. But our original problem was in x, so we replace u with 2x plus 1. So it's going to be 2x plus 1 to the fourth over 4 plus c. And this is the final answer. Okay, let's do another one. Use a substitution of the form u equals ax plus b to evaluate the indefinite integral. They actually give us a lot of information. So here, just by looking at this problem, we realize that the interior function is x plus 1. So let's just skip the part with g of x. Let's just put x plus 1 equals u. So now, if we differentiate the right-hand side, the left-hand side, we get dx, and the right-hand side is du. So now, if we plug in here, we get integral of u to the 12, and instead of dx, we put du. So again, another elementary integral, which gives us u to 13 over 13 plus c. Original problem was with u, so x plus 1 to 13 over 13 plus c. If you are wondering, how did we get this dx equals du? I can clarify that a little bit more. So let's say we had x plus 1 equals u, which u is a function of x. If we differentiate both sides with respect to x, on the left-hand side we get 1, and on the right-hand side we get du dx. If we multiply both sides with dx, we get dx equals du, the relation that we wanted. So this is just a discussion. Okay, let's see if we have other problems. Yep, we have quite a few. The interior function in square root of 2x plus 1 would be 2x plus 1. So 2x plus 1, we set it equal to u. So now, on the left-hand side, if we differentiate with respect to x, we get just 2. So we write 2 dx. And on the right-hand side is just du. So dx equals du over 2. So now let's replace everything in this integral. So integral of square root of u times du over 2. Well, I get this over 2, so I can factor it out. And integral of square root of u du. Well, in order for us to calculate the integral, we put u to a half. And so we have u to 1/2 plus 1 over 1/2 plus 1 plus c. Very important, as you probably already noticed, if the variable is x, we have dx. If the variable is u, we strive to have du. So you see, you cannot have integral of u dx in one variable calculus. So we get 1 over 2 times u to 3 over 2 over 3 over 2 plus c. So we do the math, and times 2 over 3, u to 3 over 2 is square root of u to the third. These two cancel, so it's 1 over 3 u square root of u plus c. And don't forget your original problem was in x, so 2x plus 1 square root of 2x plus 1 plus c. Final answer. Okay, another one. Let's look at the problem that we have here. So x integral of x sine of x squared dx. Well, which one is the ugly duck, basically? Which one is an inconvenient there? Well, it's sine of x squared. So that's x squared. We set it equal to u. So now if we differentiate both sides with respect to x, we get 2x equals du dx. So if we do the cross multiplying, is 2x dx equals du. You can skip this step, but I just wanted you to see what's going on there. So dx equals du over 2x. Very important, keep in mind. So now integral of x, I copy it. Sine, I copy it. X squared, well, we plug in u. And then instead of dx, we put du over 2x. So as you can see, the x cancels with x, so there is no problem. All our integral is in terms of u. There is a 1/2 here, which I factor it out, sine of u du. Well, we learned what is integral of sine of x dx, right? It was negative cosine of x. In our case, it's u. So it's negative 1 over 2 cosine of u was x squared and plus c. And this is it. Well, they might seem complicated, but you have to do a million of them so that you get comfortable. So you see we have quite a few here. Another one. Let's look at this. Integral of x squared plus x to the 10, 2x plus 1 dx. So we see that x squared plus x is to the 10, right? So let's label that x squared plus x equals du. So if we, u. So the left-hand side, when we differentiate, is 2x plus 1 dx, and the right-hand side, du. So dx is du over 2x plus 1. So now let's plug in integral of u to the 10 times 2x plus 1 times, and instead of dx, we put du over 2x plus 1. So dx is this one. Now you see how 2x plus 1 cancels? They must, because you have to get only in terms of the variable, the same variable. So u to 11 over 11 plus c, u was x squared plus x, so it's to 11 over 11 plus c, final answer. Let's see some trigonometric ones. Use a change of variable. So integral of x cosecant squared, cotangent squared, so x squared equals u. 2x dx equals du. Dx equals du over 2x. So, integral of x times cosecant of u, cotangent of u times du over dx, 2x. X and x cancels, a half comes in front, cosecant of u, cotangent u, du, and I let you finish this one because it's just a formula. Finish yourselves. Okay, let's see. We have just a couple, so let's do this one. In trigonometry, you learn that when you have cosecant and cotangent, and sometimes it's better to just change them into sine and cosine. So let's change that. So cosecant squared of x, it's 1 over sine squared of x. Cotangent squared of x is cosine squared of x over sine squared of x dx. So this is a fraction over fraction, so I'm going to write 1 over sine squared of x times sine squared of x over cosine squared of x dx. So sine squared cancels, so we end up with 1 over cosine squared of x dx. Okay, so let me see, what is tangent, it's sine over cosine, tangent of x prime? Well, that's sine of x over cosine of x, or you either learn a formula or you use quotient rule. So it's sine of x prime, which is cosine of x. So cosine squared of x plus sine squared of x over cosine squared of x. So it's 1 over cosine squared of x. So what did we just prove? We proved that tangent of x prime, it's 1 over cosine squared of x, or tangent of x is the antiderivative of 1 over cosine squared of x. Therefore, this equals tangent of x plus c. So integral of cosecant squared of x over cotangent squared of x, it's tangent of x. And we didn't even use the change of variable, so we can just leave it like this. But since they said use a change of variable, we'll take that as an challenge to do that as a second method. Change of a variable. See which one you should change. Okay, and the last one, use a change of variable to evaluate the indefinite integrals. So first I'm going to separate. Should I separate them? Or just, let's do secant of x equals u. So now secant of x prime, what is that? So 1 over cosine of x prime dx equals du. So sine of x over cosine squared of x dx equals du, or tangent of x, 1 over cosine, it's secant of x dx equals du. Okay, so let's see. Using this information, I'm going to separate. So secant to the 5 of x tangent of x dx plus integral of secant cube of x dx, tangent of x dx equals. Well, as you can see, one tangent of x and a secant of x dx, if I have this combination of these three things to the first power, we get du. So because of that, I'm going to write, instead of secant to the 5th, I'm going to write secant to the 4th of x, and then secant of x, tangent of x, dx. And I'm going to do the same thing to the second integral. Instead of secant to the 3rd, I'm going to write secant to the 2nd times secant of x times tangent of x. Mathematically, it's correct, right? So the first one gives us this piece here that I highlight on both of them. I can just replace it with du, right, on both integrals. Now the question is, what is this one? Secant to the fourth, secant to the second. Well, we use the substitution secant of x equals u. So it's u to the fourth and u to the second. How nice is that? So we get u to the fifth over 5 plus u to the third over 3 plus c. But u was secant of x, right? So it's secant of x to the fifth plus secant to the third of x over 3. So there you go. Final answer. I hope this helps.